So let's talk about the kind of functions whose antiderivatives are logarithmic functions. And just to get our thinking straight, let's start by taking the derivatives of a few logarithmic functions. Let's go in the forward direction and let's see what happens. Let B represent any constant. Find the derivatives of the following two functions: the natural log of x plus b and the natural log of minus x plus b. Alright, now the most important thing to keep in mind is chain rule when you're doing these problems. The derivative of the natural log is the reciprocal. And then I'll differentiate the inner function x plus b, but since x plus b is a linear function with slope 1, the result of that is just 1. I would say we have to be more careful when the time has come to take the derivative of g of x, natural log negative quantity x plus b, because now if I take the derivative of the innermost function, the result of that will be minus 1, the derivative of negative x plus b minus 1. So the negative 1 in the numerator level and the negative 1 in the denominator level cancel each other out, giving me x plus b again. Now this is interesting. This is interesting because we have now obtained two different functions, two fundamentally different looking functions with exactly the same derivative. So when we take the antiderivative of 1 over x plus b, we'll have to be careful to account for both of the possibilities, that natural log could be of x plus b or natural log could be of negative x plus b. And the way that we will account for the fact that the input of natural log could be either positive or negative is by using the absolute value. Here are some formulas. The antiderivative of 1 over x as a base is the natural log of the absolute value of x. And since this is the most general antiderivative, we're going to have that plus c about. The natural log of absolute value x plus b plus c is the most general antiderivative of 1 over x plus b. So if you have a reciprocal of a linear function with slope 1, 1 over x or 1 over x plus b, the antiderivative is the natural log of the absolute value. Now we have to be careful not to take this rule too far. Here is a thought exercise. What if I tried to take the antiderivative not of 1 over x plus b, but 1 over x squared plus 1? Can I still take the absolute value of x squared plus 1 and then take the natural log of that? Would that be the antiderivative of 1 over x squared plus 1? Well, the easiest way to check this, I think, is to assume for the moment that we have the positive case of just x squared plus 1, no negative sign, and to take the derivative of this, and let's see if the result is really equal to 1 over x squared plus 1. Now that is the derivative of the outer function, but chain rule steps in and says, hey, don't you have to multiply by the derivative of the input x squared plus 1? So the derivative of this function is actually 2x over x squared plus 1, not 1 over x squared plus 1. So I would have to say that this is false. This is false. Natural log of x squared plus 1 cannot be an antiderivative of 1 over x squared plus 1, because if I take the derivative of natural log of x squared plus 1, the result is not 1 over x squared plus 1. So This is a false statement. You really have to be careful to make sure that if you're using this rule, that you have a linear function, slope 1 in the denominator. Just x, not 3x, not 7x, just x. Then you can use this formula to find the antiderivative.